Turn off the bulb of your room and you are not able to see anything anymore. Have you ever wondered why this happens? Well, the reason is very simple. When light rays strikes the surface of some objects like furniture, the ceiling of your room, the walls, etc., they bounce back. After bouncing back, they enter our eyes and on the retina they forms an image of the object. This image is perceived and then processed by our brain. In this way, we are able to see various objects. Well, this bouncing back of light rays after striking the surface of various objects has a special name. We call it reflection, about which we will study in the videos to come. So, now we know that why we are able to see things only in the presence of light, because light rays strikes the surface of various objects and then they bounce back. This reflected light rays enters our eyes and on our retina they forms an image which is perceived and processed by our brain. An object reflects light that falls on it. This reflected light, when received by our eyes, enables us to see things. We are able to see through a transparent medium as light is transmitted through it. So we will learn about transparent medium, about opaque mediums and about translucent mediums in the next slides to come. Okay, so don't worry about that. We also know that light seems to travel in a straight line. That means suppose that light rays are going in this direction. They always moves in a straight line. Okay, and if we put our book in their path, it's not that they will turn an alternative path like this, right? Light cannot do this. It's not that they will turn an alternative path like this. Light always propagates, light always moves in a straight line. So the path of a light ray will always be a straight line. You got it? Now, do you know that light comes in several varieties and each category of light ray has a special name? For example, this division of light rays is on the basis of wavelength. Always remember, this division of light rays is on the basis of wavelength. So, those light rays whose wavelength lies somewhere close to 10 raised to the power 3 meters, we call them radio waves. Well, their usage is, you can say, in the radio communication, mobile communication, radio waves are most commonly used. Then we have microwaves. This is another variety of light whose wavelength lies somewhere close to 10 raised to the power minus 2 meters. Well, these rays are used in microwave ovens, most commonly used. Okay. Similarly, we have infrared rays whose wavelength lies somewhere close to 10 raised to the power minus 5 meters. Similarly, we have visible rays whose wavelength lies somewhere close to 0.5 into 10 raised to the power minus 6 meter, and so on. We have ultraviolet rays, we have X-rays, and we have gamma rays. If we carefully observe the names of these light rays, we can easily notice one thing. That is, only this part of light rays whose wavelength lies in somewhere close to 0.5 into 10 raised to the power minus 6 meters is visible to us. That is why it has a special name, visible light rays or visible rays. The rest, all varieties, human beings cannot see. We cannot see ultraviolet rays, we cannot see X-rays, we cannot see gamma rays, infrared rays, microwaves or radio waves. Right? We can only see visible light rays. That is why their name is visible. And their wavelength lies somewhere close to 0.5 into 10 raised to the power minus 6 meter. So, the wavelength of visible light rays lies somewhere close to 0.5 into 10 raised to the power minus 6 meters. So we can write it as 5 into 10 raised to the power minus 7 meters, right? Or we can write it as 500 into 10 raised to the power minus 9 meter. Or we can write it as 500 nanometers. So the visible light rays, their wavelength lies somewhere close to 500 nanometers. Being more specific, their wavelength ranges from 400 nanometers to 700 nanometers. Okay, so this way, this direction the wavelength decreases, so this direction the wavelength will be increasing, right? And we can see that the wavelength is increasing. We can clearly observe it that the wavelength is increasing in this direction. Well, there is a relationship between wavelength and frequency. As the wavelength decreases, the frequency increases, and vice versa. If the wavelength increases, the frequency will decrease, right? Energy of light rays always increases with the frequency, remember that. If we subdivide this range of wavelength that we call visible light for the obvious reason, because only light rays falling in this range are visible to us. Then, depending upon the wavelength, our eyes perceive this range of light as different colors: violet, indigo, blue, green, yellow, orange and red. So the light rays with shortest wavelength, of course I am talking about this 400 nanometer to 700 nanometer. Remember, this direction the wavelength is decreasing, that means this direction the wavelength is increasing, and that is very clear from this diagram as well. We can easily see that, we can easily observe that the wavelength is increasing along this direction. The wavelength is increasing along this direction. Okay, so the light rays in the visible range, which are shortest in wavelength, this one close to 400 nanometer, they appears to us as violet rays, as violet color. Similarly, a little more than this wavelength appears to us as indigo color. Similarly, a little more than this wavelength, wavelength corresponding to indigo, appears to us as blue color. Similarly, the light rays with highest wavelength, obviously close to 700 nanometer, they appears to us as red color. So different wavelength of light rays are perceived by our eyes as different colors. It's clear? Do you know why we named this portion as ultraviolet rays? Because if we go according to the frequency, right? If we go according to the frequency, then the light rays, the ultraviolet light rays have greater frequency than the violet rays. That is why their name is ultraviolet. Similarly, infrared light rays have lower frequency compared to the wavelength corresponding to red light. That is why their name is infrared light. Okay, of course these naming infrared, ultraviolet rays are according to frequencies. We know as the wavelength decreases, the frequency increases, and vice versa. As the wavelength increases, the frequency will decrease. Let's talk about the behavior of light at the interface of two media. When light traveling in one media falls on the surface of a second medium, the following three effects may occur. So what are the three effects? First, a part of it is turned back into the first medium. So let's observe this image carefully. This is the medium 1 and this is the medium 2. Okay. In medium 1, light was initially propagating like this, following this path, and then it was incident on the surface of the second medium, or we can say it strike the surface of the second medium. Now, the moment it strike the surface of the second medium, three possibilities arises. The first possibility is it gets reflected back into the same medium, or we can say it bounces back to the same medium. Okay, both are same. Now the second possibility is instead of bouncing back to the same medium, light rays simply enters into the second medium, and later we will learn that when light rays enters from a medium to another medium, they bend from their original direction. You can see that there is some bending. The original direction was this, but the moment it entered the second medium, it bent from this original direction. We call this phenomena as refraction. Let me write it here. We call this phenomena as refraction, and later we will study it in detail. Now there is another possibility that a part of the light ray is absorbed by the second medium. A part of this incident light ray is absorbed by this second medium. Okay, we call it absorption. So in this chapter we will only study about reflection, that means bouncing back of light rays into the same medium, and refraction, that means when light rays enters the second medium, of course with some amount of bending. Okay, so these are the three possibilities. We also know that light travels in a straight line. We know that in vacuum or air the speed of light is fastest, and it is 3 into 10 raised to the power 8 meter per second. So if we are saying that in vacuum the speed of light is this, it should be clear that in different medium the speed of light is different, and the speed of light is highest in vacuum. That means when there is no medium present, not even air. Okay, in that case the speed of light is maximum, which is 3 into 10 raised to the power 8 meter per second. Now let's talk about a bit more about medium of light. We know those substances through which light can propagate are called medium of light. Those substances through which light propagates are called medium of light. Now, medium of light can be divided into three broad categories. Number one is transparent medium. In Hindi, we call them pardarshi. Number two is translucent medium. In Hindi, we call them parbhasi. And number three is opaque mediums. In Hindi, we call them apardarshi. So, what is the difference? What is the basic difference behind the concept of a transparent medium, a translucent medium, and an opaque medium? You can easily observe this difference by having a look on this image. Mediums we can see through, that means those mediums we can see what is kept on the other side of them. We call them transparent medium. Like the glasses I am using to see objects clearly, that's a transparent medium because I can see through it, right? I can see what is on the other side of it. That is why I am using it. Right? So such mediums are called transparent medium. On the other hand, those mediums we cannot see through. That means we cannot see what is on the other side of those mediums. We call them opaque mediums. For example, the furniture, the table, the walls of your room, the ceiling of your room, the fan, etc. All these mediums are opaque medium because light cannot go through them, right? Light cannot pass through them. That is the reason we cannot see what is kept on the other side of such mediums. Between conductors and insulators, we have something we call semiconductors, right? Semiconductors. Exactly the same concept is here for translucent mediums. Translucent mediums are those mediums we can see through them but only partially. For a translucent medium, light rays when enters, they are not just being reflected back, but some amount of light is also being refracted. That means it is also entering this medium and exiting from the other side. For opaque medium, light rays when incident on the surface of an opaque medium, they simply reflect back. The entire light ray that was incident simply bounce back or reflected back from this surface. For a transparent medium, the light rays that are incident on this surface, almost all the light rays, they get refracted. That means they enter the medium of the surface. Refracted. Example of a translucent medium is frosted or ground glass, greased paper, oiled paper, paraffin wax. All these are translucent mediums. That means we can see through them but only partially because it is not allowing all the light to pass through it. It is only allowing some amount of incident light to pass through it, and of course the rest of the light rays gets reflected back into the same medium. Let's say there is a opaque medium. Okay, so let's say there is a book kept here. And my eyes is somewhere here. So light rays when incident on this surface, the surface of this opaque medium, all the light rays gets reflected back. So my eye is not getting any light ray which is being reflected from this book. That is why I cannot see this book which is kept on the other side of this opaque medium, just behind it. Okay, my eye cannot see it. But let's take an transparent medium. Okay, let's take a transparent medium. Now, in this case, if the same book is placed behind this transparent medium, then what will happen? Since it's a transparent medium, so it will allow the light rays to refract. That means it will allow the light rays to go through this medium. So what will happen in this case is light ray, they will get refracted. That means they will now enter this medium because it is a transparent medium, allowing the light rays to pass through it. Then they will incident on this book, on the page of this book, which is an opaque medium, of course. Okay, this book is an opaque medium, so it will reflect back all these light rays. They will again pass through this transparent medium. It is allowing the light rays to pass through it only because it is a transparent medium. It is a transparent medium. Now these light rays will enter our eyes. They will form an image at our retina, which will be perceived by our brain. The brain will process this image and tell us what is written on this book. Okay. If it were a translucent medium, then we could only see partially what is there, what is written in this book, or even this book itself. We can only see it partially if it were a translucent medium instead of a transparent medium. Because what happens with a translucent medium, it allows, let's say this is a translucent medium. Okay, this is our eye, again this is our eye. So this translucent medium will not allow all the light to pass through it. Okay, it will allow some light to pass through it, while the rest of the light will be reflected back. So since all the light is not being allowed to pass through it, so very little amount of light will enter through this medium, this translucent medium, and strike this book, which is an opaque object. Then it will get reflected back. Again, very little of this reflected light ray will be allowed to pass through this medium, and finally it will enter our eyes and form an image at the retina, which will be perceived and processed by the brain. So this was the end. I hope you liked the video. Meet you in the next part.